The actual binomial theorem then, let's look at that. There it is, in all its glory. And that's what we've already seen anyway. But that is the binomial theorem. 1 plus x to the power of n is nc0 plus nc1x, and so on, and so on, and so on, up to ncnx to the power of n. We can write it in some notation to save a bit of time. So we're saying it's the sum of all these terms going from k equals 0 to n, and the general term there is nck x to the power of k. nck is exactly what we saw back in combinatorics. N factorial on k factorial, n minus k factorial. And keep in mind, there'll always be n plus 1 terms, because we start at k equals 0, so that's the extra term. Not very useful just being 1 plus x, so we could extend that out to a plus b, so we've got anything. The general term then becomes nck, a to the power of n minus k, b to the power of k, so those two powers always add up to be n. First example, let's just work out 11c4. No, not using the calculator. So we put it into the formula. There it is. 11 factorial on 4 factorial, 7 factorial. But we've got some cancelling that will happen there. The 7 factorial will go into the 11 factorial, leaving me with 11 times 10 times 9 times 8. On the bottom we have 4 times 3 times 2 times 1. But of course, 4 2s are 8. And 3 will go into 9 3 times. So we get 11 times 10 times 3, 330. This is how we used to do it in the dark ages. When we didn't have calculators, we'd do that. Find the value of n so that nc5 is equal to nc8. Now, of course, the long way of doing this would be putting it into factorial notation and then trying to solve that equation. No, it works. But a quicker way is remembering those Pascal triangle relationships. If nc5 equals nc8, then I know that the 8 and the 5 must add to give the n. There's the relationship. nck is equal to ncn minus k. Therefore, n is 13. Similar sort of question if I see something like this. nc7 plus nc8 is 20c8. Again, I could change everything into factorials and solve that equation. But if I remember the relationship, n minus 1ck plus n minus 1ck minus 1 is nck, then I can look at the pattern and go, oh, hang on, k, well, that must be 8. K minus 1 is therefore 7. So in our one, n must be 19 because it would be 1 less than the one on the right-hand side. 1 less than 20 is 19. We want to find the fifth term in this expansion, but I don't want to write the whole thing out. So that's where I'm just going to use the general term. So the general term for this one, I like to write the general term as term k plus 1. Main reason I do that is because the first term, remember, is when k is equal to 0. So first term, I want to be term 1. So term k plus 1 will be 11ck. I always put the second one to the power of k, so minus 3 on b to the power of k. They have to add together to give 11 in this case, so the power of 5a must be 11 minus k. I want the fifth term, well, that will be when k is 4. Substituting 4, now we just got to work this out. So 11c4, 5 to the power of 7, 3 to the power of 4, a to the power of 7 over b to the power of 4. If I'm feeling incredibly lazy, I could leave it like that and say, oh, that's just unsimplified, but that's the answer. Sometimes you get away with that, especially when the number's getting really big. And they might even say leave it in unsimplified form sometimes. But let's work it out. Okay, 11c4, 330. We just worked that one out before, didn't we? And then 5 to the power of 7, 3 to the power of 4, putting it all together. Yeah, it is quite a large number, isn't it? What is that number? 2,088,281,250. Obtain the term independent of x. So same deal here. I don't want to expand the whole thing out. So I'll get my general term. In this case, 9ck. I'll have the minus 1 on 2x to the power of k. The 3x squared will be to the power of 9 minus k. Now, independent of x means there's no x. Therefore, the power of x must be 0. So I'm not worried about the coefficients at this stage. I just want to work out what k would be to give me a power of 0. So just looking at the x's, I'd have x squared to the power of 9 minus k. X to the negative 1 would be to the power of k. So that ends up meaning k must be 6. Now I can go back and substitute into the general term. I suppose I didn't really need to write the x's down because I know they're going to go, but they're there anyway. And we end up with, well, there's the unsimplified answer, 9c6, 3 to the power of 3 over 2 to the power of 6. Find the ratio of the coefficients of x to the power of 7 and x to the power of 5 in this expansion. So again, I'm only interested in a couple of terms here. There's my general term, but you'll notice I've used the other notation for nck here, or in this case 15ck. So 15ck, 2x will be to the power of k. I haven't bothered writing the 1 to the power of 15 minus k because, of course, that's just going to be 1. So coefficient of x to the power of 7 over coefficient x to the power of 5. I haven't bothered with the x's, they just want the coefficients. So 15c7, 2 to the power of 7 over 15c5, 2 to the power of 5. This is where I'm going to break it up into factorial notation rather than wasting time and working out what those things are, because there's going to be a lot of cancelling here. And the other one I've done, 2 to the power of 7 divided by 2 to the power of 5 is obviously 2 squared, which is 4. Okay, the 15 factorial will cancel with the 15 factorial, so that goes, that's nice. I'll put the 8 factorial into the 10 factorial, leaving me with 10 times 9. I'll put the 5 factorial into the 7 factorial, leaving me with 7 times 6 on the bottom, and that comes out to be 60 on 7. So there's our ratio. So did I actually answer the question? That's a good question, isn't it? Should I write the ratio is 60 to 7? A couple of exercises on this one. So 15C and 15E.